Hello good day viewers, welcome to Tambuwal Academy, and this is going to be our first tutorial. I realize a lot of people face challenges when it comes to mathematics, and this was the reason why I created this page. And we're going to blend mathematics from scratch, from the elementary aspect of mathematics going forward. And what do you think we're going to discuss in this tutorial? We're going to discuss about numbers, because numbers are very essential when it comes to mathematics. So what are numbers? You know, we use these numbers in so many different things. We use numbers to count objects. We use numbers to level objects. We use numbers to even measure objects and things like that. But numbers are subcategorized. So we have numbers here. We can categorize numbers into two: real numbers and imaginary numbers. So we have having categorized numbers as real and imaginary, let us talk about real numbers first. Think of any number. That number that comes into your mind at the moment is a real number. So we say that any number you can think of is a real number. But what about imaginary? From the word imaginary, you can just imagine they exist, but they are not there. Therefore, at the moment, we are not going to discuss about imaginary numbers till we get to higher classes. Remember, we are starting from the scratch. So let's talk about real numbers. As I said, real numbers are numbers you can think of, any number, but they are categorized as well. We have the rational and the irrational numbers. So let me categorize them. We have ratio. Can you remember ratio? Any number that can be expressed as numerator divided by denominator. For example, if I have P divided by Q, for which you should know that this Q cannot be equal to 0, because in mathematics we don't divide any number by 0. That is undefined, right? So whichever number you can express as P divided by Q, numerator over the denominator, that number is said to be what? A rational number, where P and Q are all integers. I will discuss about integers in a moment. Integers are just numbers on the number line. If you know number line, numbers that begin with 0 in the middle, 1, 2, 3, forward, you come backward, -1, -2 in that order. We call them integers. So any two integers you take, like 2 divided by 3, 2 and 3 are all integers. So therefore, this number is a rational number. Example of a rational number. Once you can express a number in this form. Even 5, because 5 is an integer, 5 is the same thing as 5 divided by 1. 1 and 5 are all integers. And since 1 is also a number, 5 is a number, we have expressed 5 as a fraction. Therefore, 5 also is a rational number. Even decimal numbers, 0.5. 0.5 is the same thing as 5 divided by 10. Because if you divide 5 by 10, you're going to obtain 0.5. Therefore, 0.5, which is a decimal number, is also a rational number. So let us categorize rational numbers before we come back to irrational numbers. So we have all integers. All integers are rational numbers. Fractions are already rational numbers. Then the last one are some decimal numbers. Decimal numbers. Let me drop this one. Let me finish with rational numbers before coming back to irrational numbers. You should not worry about some of these examples. We are going to take them individually and discuss in a separate videos. So integers, we have learned that they are the numbers on the number line. Fraction is a number out of whole, right? If I have a complete orange and I decided to partition it into two, I have half here and I have another half here. Each one here is 1 over 2. So you see, 1 over 2 is a fraction of complete 1. You may decide to divide it into 3. Each piece is going to be a fraction of the total orange. This is why we say fractions are also rational, right? Decimal. I say some of the decimal numbers are what? Rational, because decimal numbers are categorized into 3. Only 2 of them are said to be rational. Example of them are, let me say, for example, 0.2. We may have 1.35. This type of decimals, we call them terminating decimals, because you can see immediately after 1 decimal place, this one terminates. After 2 decimal place, this one terminates as well. Each of these can be expressed as numerator over denominator. This one can be written as what? 2 divided by 10. This one can be written as 135 divided by 100. So you see, all of them are rational numbers. Another category of decimals, numbers that are rational, are numbers like this, 0.333, so on. This type of decimal numbers are regarded as non-terminating because you can see we have dot dot. It means that this 3 is recurring. It keeps on repeating itself. So it is non-terminating but recurring, because we have non-terminating, non-recurring. That type of decimal number is going to be categorized under irrational numbers. So these are the 2 examples of decimal numbers that are rational numbers. Fractions, already you may have 1 over 2, 3 over 5. All of these are fractions. And integers, let me even draw them here. Though we are not done with integers. Under integers, we have 2 subcategories, right? We have the whole numbers, and we have the other one, which we call the natural numbers. So let me draw integers like this. The middle number is 0. If you go to the right, 1, 2, 3, 4, 5, and so on. If you come to the left, -1, -2, -3, and so on. This is a set of integers, right? But what are natural numbers? Natural numbers are just the counting numbers. Numbers you use in counting. 1, 2, 3, 4, 5, in that order. For example, if you are asked to count 20 people aside, you will not begin with negative numbers. You cannot say -1 person, it's not possible. And you cannot say 0 person, it's not also possible. Therefore, you have to say 1, 2, 3, up to 20 for you to count the whole of those people. This is why we say they are our natural numbers, the counting numbers. So natural numbers are also integers from 1 forward, right? But what about whole numbers? The only difference between natural numbers and whole numbers is the 0 inclusiveness. So if you include 0, you are referring to whole numbers. But if you exclude it, you are referring to natural numbers. So whole numbers, sometimes we say they are the complete numbers. For example, if I have a basket, this basket contains 3 oranges. 3 oranges are complete, right? You cannot say this is half a person. For example, if these are 3 people in a room, you are going to classify them as what? 3 people. If one of them is gone, you say what? You have 2 people left. If the other one left, you have a single person left. But there is no way half of this person will leave the room. Therefore, if this one left, you have nothing, 0, right? So whole number, complete. There is nobody right now. So there is 0 person in the room, or nobody, right? So I think this is all about rational numbers. What about irrational? Just the opposite of rational. Numbers that cannot be expressed as numerator over the denominator. Example, square root of any non-perfect square number. Example 2 is not a perfect square numbers, because perfect square numbers are numbers like 1 times 1, 1, 2 times 2, 4, 4 is a perfect square number, 3 times 3, 9. So 2 is not a perfect square number. If you take calculator, press this, you're going to get a decimal number that is non-terminating, non-recurring. All right? And another one, square root of 5, square root of 8, and so all these non-perfect square numbers. But square root of any perfect square number should be classified under rational numbers. Then pi. Pi is also non-rational, though we can write it as 22 divided by 7, which is just an approximated value of pi, but not exact. Another one, we may have e, which is also a number, is non-rational number. It is regarded as irrational number. Which other one again? We have so many of them. So I think this is just an introduction about numbers. Subsequently, we are going to talk about rational with some examples, integers, how we can even combine 2 or more numbers together to see the output. If you combine rational and irrational numbers together, will you get a rational or irrational? If you take a decimal number, you multiply it with integer or a fraction, or this combination, what will you get? So this is just an introduction. Thank you for watching. Do share to your learning colleagues. Bye-bye.